So now we recently looked how we have 10 milliamps of current flowing through this LED, but it's set by that resistor. First off, we have this LED here. Thanks to the 10K resistor, we're going to have approximately 1.7 volts across it. That's being sent to the base of the transistor. It's a PNP bipolar junction transistor, 100 ohm resistor right here. So we're going to get about 0.7 volts less across this resistor. That's in relationship to the positive supply right there. So since it's 100 ohms, we get 10 milliamps of current. And of course, the LED is going to need about 2 of those volts right there approximately. And the rest of the voltage will be across the transistor. That's actually how the current gets set right there. So again, you got the base voltage. That sets the voltage across the resistor, but it's 0.7 volts less. That'll be the current that flows through because the transistor will take up whatever voltage is needed to maintain that. So now, in the previous short, we looked at the voltages of this circuit. I'm going to get rid of that LED though. This is a current source circuit right there. So we actually need current flowing to get the voltage across the LED here. In relationship to the positive supply, the voltage down lower is 1.7 volts lower than the positive supply right there. That's what we're getting. But it sets that voltage to the base. And thus we get across the resistor about 1 volt, about 0.7 volts less. This is a PNP bipolar junction transistor. The resistor is to the emitter. And so that has 1 volt. What that means is to get the voltage across that 1 volt, we have to have about 4 volts across the transistor right there. And the voltages have to add up because we have a 5 volt power supply powering all of this.